2024 was a weird year for JavaScript frameworks. We didn't really get some big new invention or paradigm or framework. We just kind of kept moving along to make the things that were already going go a little bit further. It's weird to say, but the framework that changed the most in 2024 was Angular. But we're not in 2024 anymore. We're in 2025. And maybe if you're watching this later, 2026, 7, 8, why are you here? For everyone else, 2025 has started, and Ryan Carniato, the creator of Solid.js and probably the single person who knows the most about every framework, wrote an awesome article all about it. The article is so awesome, this is my second time recording this video, because the first time I recorded it, I got 6 paragraphs in before I made the most intense set of diagrams I've ever made. All of these are their own separate video now, by the way. I don't know what I ended up naming it. The current plan is all the different ways to render your JS app. I'll be sure to link it in the description if you want to see me making these diagrams and in-depth explaining all of these render strategies. But this video is not about the render strategies. This video is about how frameworks will change and evolve in 2025. So if you don't know what an isomorphic SPA is and you think it's important to, maybe go check that video out first. At the very least, we'll be coming back to the diagrams and touching on it. But our goal is to better understand what's going to happen to JavaScript over the next year. Before we do that, I got bills to pay, so let's hear a word from today's sponsor. Today's sponsor is Prisma, and they made a DB. You might be tired of seeing new DB providers, but there's a couple reasons you're going to love what they built. First off, it is literally 3 clicks to deploy. That's so simple. It's also free, like really free. The pricing is super generous. You get 5 projects on the free tier, and each of those gets 2 environments, so you can handle dev and production. You don't have to eat a separate database just for that. They also make things easier for us serverless folks. They have auto-scaling connection pooling built in, so you don't have to worry about using all of those connections up just because you're running on Vercel or Netlify. They also have real-time, which is dope because adding that to your database yourself isn't fun. Now you can literally just stream in the results because it integrates directly with the Prisma ORM. And there are a lot of really cool things they do with that. Along with the connection pooling, you can cache on their edge network. You can literally make a Prisma call, give it a cache strategy, and now this value will be cached on the edge. You don't have to connect to a database and wait for the lookup anymore. And you can directly evict it if you need to as well. It's really cool having that at a database level. I'd never seen or even thought about that before. But for those of us that don't just have one server, man, this is really cool things that they're building. Thanks to Prisma for sponsoring. Check them out today at soydev.link/PrismaDB. JavaScript frameworks heading into 2025. I admit, I wasn't sure I'd be writing this article this year. It's easy to write articles that excite people about the potential of new tech, but 2024 was a year of coming to terms with reality. Past several years have been an exploration to discover the unknown. We entered this year excited. It was finally time for these advancements to find refinement. They have. But one thing is abundantly clear. The quest for simplicity hasn't resulted in making web dev simpler. Yeah, most people feel like web dev has gotten more complex, and I understand why they feel that way. I think it's checks and balances on every side, but the overall vibe is not that web dev got simpler. That sucks. Clearly, some things have become easier to do, but the overall picture hasn't simplified. We already knew this, but something changed in 2024, aided in part by pressuring from the global economy, tightening budgets, and keeping solutions on the safe path. I think it's finally been acknowledged that there are no silver bullets. Difficult problems are always difficult to solve. There is a separate problem here where we started using the solutions for difficult problems to solve much simpler ones, and now everything is more complex than it needs to be. But we can't solve difficult problems with simple solutions. The size of the problem and the size of the solution should roughly fit each other. If you're using Rust or Zig for your REST APIs, or you're using React for your blog, you're using a solution to a big problem for a much smaller one. And I think that has resulted in us over-indexing on trying to find simplicity instead of acknowledging that certain things have to be complex. And I love how Ryan put it here. Difficult problems are indeed difficult to solve. We can't pretend there's a magic silver bullet that will do it. It isn't just the tools that are complicated, but the problems themselves. It has taken hitting obstacles around every corner while going back to the basics to only reinvent the wheel to return to that fundamental place. It's a sobering thought, but it gives me hope in 2025 that we can take some time and reevaluate. And that starts with reflecting on 2024. The promise of the server. Making things server first has been the narrative over the last 5 years in Frontend. This is not a new concept. The web was born on the server. But after a decade of client-centric single-page apps, it was clear that the pendulum had swung quite a bit too far, especially for page load-sensitive websites, which did not benefit as much from the increased interactivity. The pandemic only amplified this, with both the rise of online shopping habits and the influx of capital driven by low interest rates. The first time I record, I went on a whole rant about how there hasn't been a new front-end framework in a while, and I'll shorten it. There hasn't been a new front-end framework in a while, and a good part of that is because a lot of them were being driven by investment. Like, people don't seem to know this, but like SvelteKit is mostly maintained by Vercel devs, and Vercel raised a lot of money from venture capital. Astro is its own separate venture capital-backed company that has investors. Remix was originally invested in by OSS Capital and has since been acquired by Shopify. Solid Start is Ryan doing his own thing. Quick is Mishko, the creator of Angular, doing his own thing. Fresh is part of Dino, and I'm almost positive Dino is VC funded. Yeah. Dino is very fundraised. They're doing okay. And Analog, which is similar to Solid Start and Quick, where it's just this case, it's just Brandon Roberts trying to make Angular usable for full stack development. Cool stuff. Oh yeah, Quick is Builder.io, and Builder.io is also VC backed. So the only things in this list that don't have VC money of some form are Solid Start and Analog, which is kind of crazy. The last couple of years have seen single page app influenced isomorphic, which is the same code running differently on client and server, approaches up against multi-page app influenced split execution models with islands and server components. And those approaches are in a search to find a universal solution for all. I am not sure if one exists, but I'm excited to see what Ryan has to say. And if these words mean nothing to you, your mistake. Go watch the other video. I recorded it for a reason. That one took a while. My poor editor slaved over it, so it's a good one. I promise you. It's a diagram video. Those are my best ones. Go check it out. And do not complain about how long it is. You're the worst commenter. If you're about to leave that comment saying, I missed when your videos were 10 minutes long. My videos should be 3 hours long. Shut your face. Anyways, the long ones were where the value is. Enjoy them. It's an exercise of two opposites trying to approach each other in the middle. This has resulted in some amazing developments in routing, like the Next.js app router, as well as view transitions in routing, as well as tech like server functions, optimistic updates, server islands, single flight mutations. No mention of out-of-order streaming, Ryan. That's unexpected. Yeah, there's a lot of these pieces that allow for a URL to behave in different ways. So when I go to one URL, it does one thing. When I click a link, it does something else. When I load a page, all the different things. It's funny. I guess that's old to me. It's his response to me bringing up out-of-order streaming. It's hilarious because I'm still trying to explain this. Like, I just was at a Laravel event yesterday. I spent half the time trying to explain out-of-order streaming to the team building Inertia and building all of the routing stuff for Laravel. I did the same thing when I was at ElixirConf last year, and I convinced the team building Phoenix as well as Elixir, Jose Valim himself, that there was so much benefit from the out-of-order streaming patterns. So yes, to us, it feels old, and I know you were doing it back in 2019 with your crazy eBay stuff. Oh, God. Marco, yeah, I know you've been doing these things forever, Ryan, but to the rest of the world, to most people doing web dev, they probably won't even think about what out-of-order streaming is, but the first time they've touched it is going to be Next App Router with suspense boundaries. So I would personally have absolutely have included out-of-order streaming as part of this revolution with routing. But I totally agree with you. Like, the focus right now isn't the client or the JS that we're running on our devices. The focus right now is entirely on the server and how the URL, the generation of content, and the client all work together. And there have been some cool things going on here. Quick breakdown of all the terms. I know people are going to be confused. Server functions are a function that the client can call. So instead of just hitting an endpoint with JSON and getting back JSON, a server function feels more like you just wrote a function and called it on the client. Usually there's some compiler hack that either binds it to an arbitrary URL or creates some thing in the background that you post to. But ergonomically, it should feel like you just write code and then call it on the client and it behaves. Optimistic updates. Wait, Ryan, you didn't put out-of-order stream, but you put optimistic updates. Optimistic updates, I've been doing those since 2015, man. Optimistic updates means when a user does something, we show the updated state before the server confirms it. So if I post a comment, it should show me the comment before the server actually writes the comment in the database, because I don't have to wait for the server back and forth and just see an empty thing up until then. Optimistic updates are lying to the user that a thing is done. Server islands are the idea of having parts of your HTML where this part doesn't come through the initial response when you go to the page. Instead of getting the whole HTML page, you get most of it with little blocks in it that say, hey, this part's not done yet, this part's not done yet. And then either the rest gets streamed in with out-of-order streaming, or usually with server islands, what it means is those blocks have a little bit of JS that goes and requests the rest of the HTML from the server to fill those parts in, as well as single flight mutations, one of my favorite things on the list. Instead of I post some data, like I leave a comment on the blog, the server says, good job, thank you. And then I have to go fetch from another endpoint to get the updated content. A single flight mutation is I post the comment and the server responds to that post request with the updated state. Somebody asked in chat, this may be stupid, but what does it mean when I say server? That is a long-winded question. I'll give the quick short answer first, which is the server is the thing that when you go to a URL, generates the response. So it could be a really simple CDN that sends HTML. It could be a thing that runs JavaScript in Node that processes your request and responds with JSON. It can be a thing that is running right in front of your database in Go or Rust or whatever. When I'm saying server here, I mean the thing that resolves the content of a URL. Usually what we're referring to here is a Node.js-based or JavaScript-based runner that exists externally that is owned by the developer of the service you're using that a request is sent to and a response is generated by, usually. So a server function means you have a function that like adds a row to a database. So you write that in server code, and now on the client, I can import that function, and it doesn't let the client access the database. The client can't just write to the DB arbitrarily, but they can call that function, and what it's actually doing is it's hitting an endpoint that was generated to tell the server to run that function to go do something. But the server in all of these is code running on a box that the developer either owns or rents that resolves a URL to something. And all of these wins are effectively ergonomic wins in how we develop those relationships between the server and client and how we use the data when we get it. And as I was saying with SingleFight, the thing I love so much about it is instead of having to get a response that says, hey, I did my job, and then go back to the server to get the rest of the content, you just send the change down as part of that same request. So there's no more back and forth when data changes. One other thing worth considering when you think about server here is it might not be the backend that is your whole API. You might have a team that wrote everything in Go and Python and whatever other technologies, connecting to the database and managing all of that. So you might think your front end has to just be an HTML file that loads JS and then hits those APIs. It doesn't have to be. There's a pattern called BFF, backend for front end. And I think pretty much every single website benefits some amount from having a BFF. Even if you want to keep all your APIs and everything else on a traditional API backend, written in whatever language and stack you want to, having a layer that lets you build a stronger relationship between the front end and those APIs and data is great. Most websites benefit from having a server that is built for the website, not built to arbitrarily serve like JSON. Because having a server that can do a little bit more with the HTML and the JS and those parts gives you all of these superpowers that make the experience for the user significantly better. Doesn't matter how good your company is at Rust, having this tiny, thin backend layer that just calls the Rust APIs and generates the right HTML, it's okay to have that little bit of JS, because if you're not running some JS on the server, you are not giving the best experience to your users. And that's not a take that I am talking out of my ass because I love JavaScript. I actually stole that take from Ryan himself. I remember the first time he said that in a live stream, and it was one of those rare moments in recent times that broke and rewired my brain, where I was thinking about it not as JavaScript backends versus the other backends anymore. And like I knew the BFF, like backend for front end pattern. The thing that broke my brain there that I was really hyped about was the realization that every website benefits from this. And it's almost irresponsible if you're building a website with users to not have something going on in between that and whatever else your backend is. If you're hitting a database directly, cool. If you're hitting another API, cool. But BFF, backend for front end, it means your front end is better. And yes, Hobbit, I am saying this. If you don't use JavaScript on the server some amount, you are almost certainly making a bad website. Like, almost certainly. Go check out the end of HTMX video if you want a more nuanced take about this relationship. But you have a pretty hard cap for how good of an experience you can make for your users if you're not running some JS on your servers, almost certainly. Anyways, the harsh reality is once you build that BFF and then you start using all the patterns here, things stop being as simple as they might have seemed in the past. I would argue yes and no. As we saw in the diagrams, the SPA way has its own levels of complexity, but most devs don't even know about it. And that's the weirdest thing. I know for a fact the average React dev is building this way. I would venture to guess that the average React dev doesn't understand how much of this is going on. I even see it in chat. And like my chat on Twitch isn't your average React devs. They know what they're doing for the most part. And they don't know all of this is going on. They just write it. But when you write with a BFF pattern and you write using these new routing things, suddenly you're thinking about these relationships a bit more. And that will inherently feel like complexity because previously you never touched any of it. It's a weird example, but a similar thing that happened to me a while. I got in a fight with the CEO of a GraphQL company because he did an article, GraphQL versus tRPC. And in this article, he was trying to demonstrate how much simpler the code was if you used GraphQL instead of tRPC. tRPC is an easy way to write your TypeScript server functions where you can call them on client without having to write a schema. GraphQL is a great way to make your front and backend teams who hate each other actually talk to each other in a way that makes some sense. The article was written in a really weird way, though, because it would show the React client code for the GraphQL side and say, look at how simple this is. And then it would compare it to tRPC, showing the client code and the server code. So if we were to view this slightly differently, we'll say, here's the tRPC box. The tRPC box has these two pieces that fill it up. We have the client and the server. The box is as big as these things expand it to be. If we were to compare this to GraphQL, let's say theoretically with GraphQL, the client part is less complex, so this is smaller. Now let's say you're a front-end dev, so you don't care about that part. Wow, GraphQL is so much less complex than tRPC. Why would anyone ever use tRPC when GraphQL is so much easier? There's a reason. I would argue, first off, that they're lying here. Someone who's implemented a lot of GraphQL in a lot of places and also was a keynote speaker at the last GraphQL conf. I'm not anti-GraphQL. The complexity is pretty big. That said, even with the GraphQL client-side complexity being bigger, if you ignore the server side entirely, it still probably averages out to being slightly smaller in terms of the overall complexity than the client plus server side. Actually, no, it doesn't. That's a fucking lie. I just did a video, 1 app, 5 stacks, where I built it with GraphQL and I built it with tRPC. And the full stack with tRPC had less TypeScript code in it than the client only using GraphQL, because setting up the client of GraphQL is complex. But if you lie and pretend it isn't, cool, we'll do that. We'll go back to what I was saying before. We'll pretend the client is smaller than it actually is. No one who is even kind of good faith will ever say the server is less complex in tRPC or a REST-based system than a GraphQL system. The reality is you basically need a PhD to do GraphQL properly. So if you have the goal of convincing stupid web devs that GraphQL is better than tRPC, all you have to do is make sure they don't look past their tiny little client-sized box. So if you write an article saying that tRPC is more complex than GraphQL, and the word resolver doesn't occur a single time in it, you're a liar and a bad person, and you should feel bad about it. And I have let that author know how I feel long ago. If you were there, you were there. He has since personally apologized to me because he realized how fucking stupid he was being. The point I'm trying to make is it's very easy if you only look at the box that you are currently operating within to ignore the complexity adjacent to it. And the thing that makes tRPC great isn't how well you can ignore the server from the client or how well you can ignore the client from the server. The thing that makes tRPC magical is how well they work together. If you want a new API on the client, you just go write a new function on the server. You don't have to reshape it on the client with a different query. You just make a new endpoint, you copy paste it. It's fine. You should have a bunch of different bespoke endpoints in tRPC for the client-specific needs. That isn't more complex because the whole story from back to front is way simpler. And sure, if you compare the size of these two clients, it's like, wow, tRPC is more complex. Why would you touch it? It's not that simple. I think we're seeing the same thing here with single-page apps. One of the crazy things that React did is it made web dev able to be more complex. All of a sudden, when we were building applications for the web, we weren't limited on the HTML being loaded. jQuery helped a lot there, but tools like Webpack, React, and TypeScript let us go from having 10 to 100 people working on our websites to thousands working in the same code base, which is just insane when you think about it. But with that, frontend has gotten so complex that we now have principal plus level engineers that do nothing but live on the client. Their whole job, their whole life, their existence, their decade plus of experience occurs after the network request has responded and given them their content. You could make a full great career from Webpack down, not touching the backend at all. I am not like that. Most of my career was backend dev. I came to frontend late. I know it doesn't seem like it now, but I did. So when I saw the frontend tools and technologies starting to embrace more of what the backend could do to make the front end better, what I saw was all of this complexity and chaos being reduced to a much simpler model. Where is it? Down here. The isomorphic SPA. The complexity here has been reduced a ton at the cost of having to understand this part. The reality is that I already understood this part because I'm a backend dev. I know how these parts work. But if you are a web dev, that has mostly ignored the relationship between the browser and the server beyond fetching from an API. And you don't really pay attention to what goes on up until this line, effectively. Like, you don't care about how your website works until you have passed the line of it rendered. Then everything we're doing right now is going to seem really complex. But the reason it seems complex is because you've been ignoring the complexity. You have pretended this part doesn't matter, and I hope the other video I recorded helps convince you that you should understand this part. I saw people in chat saying that they're going to go rewrite their apps because they finally understand certain things that were going wrong. Every React dev, every web dev should know about this, but they don't. And the fact that we are reducing the complexity here by adding a bit more pieces there does not mean the whole is more complex. It just means that you can't lie to yourself and pretend the server doesn't exist anymore. And I cannot tell you, like, if I've learned anything being a backend dev who moved to frontend, it's that the average frontend dev from the last 10 years likes to pretend the backend isn't their problem. The same way backend devs like to pretend the frontend isn't their problem. It's an adversarial relationship that is centered on this idea that you're pretending the other half doesn't exist. And I hate when devs do this. I love having the whole picture. I might not be as deep on like memory management as Primogen or Casey Muratori is, but I know what it is and what it does. I might not be as deep on CSS as someone like Josh Comio, but I know it well enough to communicate his message. I love piecing together the whole picture. So what I see here is a lot of complexity on one side, shifting to less complexity on the other. What a front-end dev sees is, wait, I have to know about servers now? That's so complex. That's so much harder. My favorite example here, and if you know, you know, if you don't, you don't. I had to teach Dan Abramov what a cold start was. The guy who made Redux and helped lead the education efforts into the new era of React didn't understand what a cold start was and how it would affect rendering your React apps on the server. I had a Twitter space in 2022 where I explained in detail what a cold start was and why it would affect him while he was boarding an airplane. Wild experience. But that's the reality. So you can have a deep, experienced, fulfilling career as a front-end dev that barely understands servers. But as the tools evolve, we're being encouraged to know more about servers, and most people are going to have their brain shut down feeling like it's way more complex. So while I agree with you, Ryan, things aren't so simple anymore. I think this is less that complexity has gone up and more that the complexity isn't being hidden or running in the browser anymore. That's a fair point, actually, Ryan. It's not just that it requires more knowledge, but also the code and the build processes too. There's a whole separate rant I need to do at some point, which is like what Webpack actually did. Because Webpack making most websites built by default instead of like compiled or quickly transformed or not even just written statically by default has allowed us to exponentially increase the tooling and complexity for any given app because we now take it for granted that our JavaScript has a build process. And that build process now also spits out node code for a runtime. And yeah, the going from the files in your code base to an app part, absolutely, that has gotten more complex, especially when you consider the complexity of like this edge worker and setting that up properly. Yeah, you know, I take it back. I agree. This is a great talk that Ryan did back 6 months ago, Facing Frontend's Existential Crisis. Highly recommend checking it out. Linked in the article. I remember watching this when it happened, but I haven't seen it since. So I'm going to rewatch that later myself. It's been incredibly difficult to actually measure success here. We've seen benchmark fails. So this is actually fun. I have a whole video about this where a benchmark was done comparing the server-side rendering performance across all the new JS frameworks that do SSR, and it was not good. Check out my videos about SSR benchmarking if you want to know more about that. Everyone from Rich Harris to Dan Abramov to Ryan to myself all jumped in to try and fix it and make the benchmarks more useful. But that's far from the only problem. We've also seen performance wins being attributed to new tech when the root case was actually somewhere else. Vercel's partial pre-rendering, which I talked about PPR a little bit earlier. I have a lot of videos, but if you want to understand it better. It's a fun call out from Ryan. I see now why he said this is going to trigger me. In hopes of understanding the Next.js partial pre-rendering as well as Astro Server Islands, I made solid start versions of the demo that doesn't do either. No pre-render, also no partial hydration. Deployed it to Netlify and the Vercel Edge. Vercel's partial pre-render does outshine its edge renderer, but it's comparable with other edge solutions because rendering at the edge is not super expensive, depending on the framework. Optimizing image preloads makes a bigger difference than any of this. I absolutely agree there. Like most things feeling slow, so much of it comes from images. There's actually a really fun demo a while back where Remix was trying to show how much faster it was than Next.js for an equivalent site. And they used the optimized images from Next. Like the images in the remix version were tagged as _next/ because they were grabbing them from the next deployment, because the site, despite being on the books and in the network tab faster, felt way worse because the images were slower. So despite the fact that their framework was faster, they relied on Next's image management because it looked slower otherwise. Funny enough, Ryan just said in chat he did the same thing. He used the optimized images from Next for his example here. So we can see in the example, Netlify Edge versus Vercel Edge versus Vercel partial pre-render. The Vercel partial pre-render comes through at around the same speed as the Netlify Edge does. Actually, I was talking a lot about this with Matt Billman. The Netlify Edge is a much better edge, to say the least. Where the Netlify Edge, it's using some of Dino's really cool, like globally distributed runtime stuff. It is my understanding right now, and I haven't confirmed this, but it is my understanding that Vercel's Edge is using Lambda at Edge or some other crazy AWS tech that has to be routed through a gateway before it can start going, which adds an inherent penalty to the whole process. Vercel's partial pre-render can skip some of that penalty, which is nice. But it also means that Vercel's partial pre-render, where it saves the static shell and then renders the rest, isn't meaningfully faster than Netlify's Edge. If anything, it might be slower at times. So very interesting call and thing I need to think about more. I do really like the idea of static parts being static, even if like Vercel's implementation isn't right yet. Static should be static and dynamic should be dynamic, and no one's cracked the path there just yet. But it is painful to see that the tech that I am most hyped about in the space right now, which is PPR, isn't performing better than just rendering on the edge anyways. Yeah, I have feelings. Not wanting to wade through the mess has led the conversation back to more traditional server approaches, ones that exist outside of SSR, ones where you aren't trying to run a client JavaScript framework on a server. It's always been a great choice for projects where it makes sense, but it's also pretty uninteresting. We wouldn't be where we are if there wasn't a need to improve upon what came before. And that can take a lot of trial and error. The simplest tool for the job is the correct answer. When the problems cease being simple, you'll want options that scale with you. 2021 and 2022 were a reset to a simpler base and a return to our beginnings on the server. 2024 was the reminder that simple doesn't always cut it. Compilation to the rescue. Oh boy, is this going to be my last framework video? Just a spoiler hint for the future, a video I've been planning for a bit. React is the last framework. I have some fun things I want to say about that. We're not there yet, but eventually. So we have the lightweight syntax in our framework, but the compiler is the one doing all the heavy lifting. Compilation is an ever-present aspect of JS development. Whenever we've hit an obstacle, whether it be a browser feature that isn't supported, clunky syntax, or the ability to address shortcomings of the language, we just build a compiler for it. It's so ubiquitous at this point that standards committees are considering going in a different direction for introducing new features. This is the JS 0 thing I talked about. They're thinking of having JS be a much more minimal set of things and letting compilers like Webpack and Babel add new features. So instead of having like ternary operators, they would compile to traditional if statements. The ternary operator would just be syntax sugar in the new JS sugar standard that can move faster and be implemented by compilers instead. I think it's a terrible idea, but I get why they're saying it because JS is such a weird moving language and so many people using JS are using a compiler anyways. It's a fair point Ryan made here that compilation and bundling are the core of how modern JS apps are created, but they're also where the complexity tends to come in JS tooling. I'm sure Carson over in the HTMX world is laughing at us. Benefits are immense though. Types, linting, tree shaking, code splitting, minification, isomorphism, macros, DSLs, monolithic authoring, and distributed deployment. If you don't think web dev is way better than it used to be, then you just weren't building real apps. That's how I fundamentally feel. I'm not saying it isn't more complex. I'm saying it's just way better. Every advancement in the past 15 years in this field has been built on the foundations listed here. There's no alternative that could even remotely be considered adequate by comparison. Call it unfortunate, call it a limitation of the JS language, call it necessary complexity, but to deny it is futile. Yeah, we are fully aligned here as usual, Ryan. However, if we want to understand complexity, it is at least important to understand the source. The most interesting development in 2024, thanks largely to both the release of React Compiler and Svelte 5 Runes, is how muddied the conversation has gotten. Fair. I just posted a video about how people are getting less happy with JS over time, and I think this is part of it. React Compiler is a really interesting one because I don't feel like anyone's really talking about it. Despite it being so cool and fundamentally changing how we should be thinking about React, no one cares. And everyone's mad about Svelte 5 Runes because it's forcing you to acknowledge that magic syntax only scales to the size of your framework. I've definitely seen interesting things because of these, though. On one side, we have the React compiler, which is an auto-optimizing compiler that transforms code in a way that reduces unnecessary re-execution without manual intervention. If you haven't seen my React compiler content, you should watch it. It's good. But React compiler is effectively adding all the use memos and use callback calls to your code to prevent re-renders happening unnecessarily. And it can do it about as good, if not slightly better job than the best React engineers can, while letting you delete a bunch of code that makes React harder to write. What I'm excited about there isn't just that like, oh, I don't have to write memo anymore. It makes maintaining my code easier. It makes code reviews easier. And probably most importantly, it makes the code easier for AIs to generate because I don't have to worry about all the weird memoization behaviors. The compiler does that. So we have a simpler syntax that we already have a lot of references for as we generate and write the code of the future. And it's funny because the React compiler is actually quite similar to how Svelte 3's compiler worked back in 2019. But on the other hand, we have Svelte 5 runes, which brings a syntactical sugar over a fine-grained signal renderer, which is similar to what Solid added back in 2018. These are two major compiler projects that couldn't be more different, that called into question the fundamental nature of both projects. React acknowledging that re-renders do matter enough to optimize around, and Svelte trading away its minimal syntax for a more expressive language with increased capability as well as a better fundamental basis for performance. Ironically, these stances are both exactly opposite of the initial selling points. This was really funny. I did a meme a while back because people were saying that Svelte so much simpler than React. It was because the syntax wasn't JavaScript. They have a compiler that did that. The React syntax was a lot closer to vanilla JS. Now the Svelte syntax more clearly indicates it's doing something here by giving you that. It's actually closer to where React was, and React's kind of going where Svelte was. We're all trading and going back. The way I describe this, everyone likes to think of change as a pendulum. So if we have just JS on one side, and we have compile it, bro, on the other side, people think that we have like a pendulum in the middle here that swings back and forth between the JS and the compile it, bro, where we're just constantly going back and forth between the two. It's my belief that these are a spectrum that has a different axis on it. So the horizontal axis here is from just do normal JS syntax to compile it. But vertically, there is quality of tools we use. And while I agree, we do go back and forth here a lot, I don't think it is a back and forth where we don't increase the quality. I think as we go back and forth, it's more of a spiral staircase than a pendulum, where we are going back and forth to find the best solutions between these two paths. So yes, it seems like Svelte and React has traded philosophies, but I think that we are constantly evolving the quality of the things we use, and most importantly, the quality of the apps that we can ship and the size of team it takes to ship those things. I was able to build an app that is pretty much the full functionality of Zoom myself. That's insane. That's so cool. That's something like Ping. I get all the functionality working before I had a team helping me with it. I'm not going to say it was pretty, but it worked and was being used by huge streamers like Iron Mouse literally 5 days after I had started this as a side project. And that's because the tools and technologies have evolved there. And I think we need to acknowledge that, yes, it feels like we're going back and forth, but you need to pay attention to how bad things were previously, because just vanilla JS in the 2000s is very different from feeling like vanilla JS today. Compilers in the old days are way less powerful than the compilers of today. Like the React compiler is such an achievement that to say that it's just them copying Svelte is to miss the entirety of what's going on here. So yes, we are going back and forth. And I know Ryan agrees here, even said it in chat. To talk about it, people think compile stuff is just JS. That's been the most difficult thing to talk about. Yeah. This wasn't the role of your article. This is the role of me adding these nuances. Yeah. People calling old React and compiler just JS. The compiler is not just JS. I'm with you there fully. You call it the right thing. I just wanted to add the nuance of the spiral staircase versus the pendulum. This is a fun call out about the Svelte 5 runes versus compiler. Both increase the complexity of our tooling compared to existing approaches. To be fair, most devs are probably not going to feel that. If I go to my next config for this app that is using React compiler, here's all the work I had to do to add the compiler. It's doing a lot more under the hood for me, but the complexity I feel, I would argue that the React compiler has been the easiest technology I've adopted in a very long time. You just turn on this flag and it just works, which is, it's a magical feeling to the point where I think it's why no one talks about it, because there's no controversy with the compiler. There probably should be though, and that's what we're here for with this article. The verdict is still out on whether these changes will ultimately be good moves for these projects. The common ground is the foundation that we build upon continues to get more complicated as we attempt to create solutions to make development easier. Yeah, that is fair. The difference being who owns the complexity. Like, to go back to the analogy earlier with the tRPC versus GraphQL, if you only own the client side and tRPC forces you to also own the server, tRPC looks disgustingly complex. Why would you ever touch it? But if the client and the server are both things that you're thinking about, obviously tRPC is the easier solution. What if, instead of this being client-server, this was React with memo calls, where we have like core React syntax, and here we have nuances of memoization. I would argue that the nuances of memoization are actually quite a bit bigger than the core React syntax. Learning how to use memos and callbacks in the render method properly is quite a bit harder than just writing vanilla standard React code. So if this box represents the complexity that the dev building the app works with and owns, because you have to own this React code in your code base, obviously, but you also have to own the nuances of the memoization and the performance, and you better be using things like React Scan and the million lint stuff so you know when you're over-rendering. If the React compiler succeeds, you only have to own the core React syntax part. You no longer have to own all of that nuance. The result is more complexity, as we see as we scroll to the right here. A compiler that handles memoization for you. That is a big, complex thing, but you don't own it. React team owns this. App devs own this. So if you're on a front-end team and you only own the client and the backend team owns the server, you're not feeling the complexity of that GraphQL adds. Like, GraphQL makes life for backend devs way harder so that we can have a slightly better experience on the front end. React compiler makes the experience for the React team way harder so that we can write simpler code. And to be clear, it isn't just us. This also allows for simpler code to be written by AIs, because AIs no longer have to think about these nuances. That makes it way easier for an AI to write code that is fine and not have to do things wrong. And I'll go a step further and say that this kind of cements React as the final framework. I will do a more dedicated video on this eventually, as I mentioned before, where React's the last framework. A lot of the reasons we reach for other frameworks have to do with this being complex, not being able to do different ways of updates like signals that perform better, not being able to export different things that make more sense. If we just keep increasing the complexity of the compiler via a team of experts that are really good at this, and the React core syntax never has to change, we never have to worry about the AI not having enough data, because the data all can be collected from the decades of code written this way. We have the data, we have the React code. If the React code can output something that is more powerful, more performant, or has more functionality, neither we nor the AI have to learn anything. The decision here, it feels like the React team has chosen to offload all of the things that make React a worse framework until you learn how to fix them, and just take those problems away. Server components solve a lot of the data management part this way. Compilers solve a lot of the syntactic and actual writing ergonomically part this way. So this is one of those rare times where Ryan and I actually disagree. I have the opposite opinion. If you constrain the language, you lose the ability to express intent. This is a tough one. I think that React syntax didn't clearly communicate intent a lot of the time. I did a video about the React compiler and performance in apps like this. It should be out by now. If it's not, I'm sorry. It'll be linked in the description eventually. This is the demo. We have these three boxes. We have a counter, you click, it increases. We have a color picker, and we have a slow component. This component renders 10,000 boxes. All of them are part of this parent demo component. We see the use state here for count. We see the use state here for color. When I click the increase here, you'll see React Scan running and showing us when things update. You see everything updates when I click, and it takes almost half a second to re-render that. Watch what happens when I use the color picker. See how laggy that is. I am just dragging the cursor around, and it has to catch up, because every single time it moves any amount, it has to re-render all three components, which would be fine if it was just re-rendering these two because they're fast. But since one of them is slower, or imagine a giant app with a lot of them, even though slow component doesn't use any of those props, it will still re-render when either of these things change. And that's the problem with the default React model. And it is surprising it doesn't matter more than it does, but it does. If I was to go memoize all of these parts, we'll even do it. I'll memoize slow component renderer, and we'll wrap this with const slow component equals react.memo slow component renderer. Cool. Wait, why is it still re-rendering? Here is where we have to get into the nuances to make these things more complex. See here with slow component, I have this unused prop being passed to it. I added this because at the time I did this demo, React Scan wouldn't show you the name or the highlight of a thing being rendered unless it had props of some form. So I gave it this fake unused prop. There's a nuance here though. Because I inlined this object, it is redefined on every re-render. So it isn't memoized because a new object is unique. And even though the component is memoized, it sees a new object being passed to it. If I change this to a bare string, like just nope instead, now the memoization does what it's supposed to. And if I had moved the object out, so it was static, so const demo object equals that, and I pass that here instead, now the object doesn't change between renders and it still works. But if I was to do something simple and stupid, like let's say, oh, I want to do something else with this, or oh, I want to use it in effect or something. So you just move this innocently here. That move just nuked the performance of your app in a way that you would not have intuitively guessed, no matter how good you are at React. Most people would not have caught that that small change is going to destroy the performance of your app because they're going to look and they're going to go check and they'll be like, oh, yeah, we memoed the slow component. It's already memoized. We don't care. But there are so many of those that when I did the video demoing it, I went out of my way to write everything properly memoized and still hit like 12 cases. Another one here is this on change. We're defining this function on every single render. So even if we memoized it, this is still going to rerun when it shouldn't because this on change is defined there. Same with this on click. This on click gets redefined on every render. So even if we memoize counter button, it's going to rerun. I bring this up because we're talking about intent. When I move this object from here to inside the function, or when I inline this object here, it is not my intent to re-render the component every single time. That was not what I or any other dev was thinking when they put an object that is effectively a static constant here. They were just doing the thing that is more readable and easier. We could add a bunch of lint rules to stop us from doing stupid shit like this. We could make our code harder to write. We could force our devs to const like color changer equals use callback. And now I have to like go deal with the types of this where the on change here, it's a value or it's a string. So string, set color E, import use callback, pass that here. Then I have to go do the same thing for the counter. Const color counter changer, use callback, set count, move that over. You get the idea. If you do this for all of those and you have to memorize the stuff. What if you didn't? Just going to git stash all that. Now I'm running the React compiler. This code is as simple as it can be. We're no longer memoizing the function here. The word memo doesn't occur in this code really. Neither does callback. None of those things exist anymore. The code is simpler. We can just inline things like that. But now when I go here, only the part affected is being re-rendered now. None of the other boxes are actually rendering again. I would argue that the intent I had as a developer here is being better handled now with the compiler than it was before. Because putting an inline object here was not intending to trigger this component to re-render every time. Putting a function here wasn't intending to redefine the function every time I render the file. The intent here was to write simple code that describes what's going on. React didn't let it be that simple before. The compiler, I personally feel, is better encoding the intent I had as the dev. And that's what makes it such a magical technology. And it's also why I'm excited for how this is going to affect AI stuff, because AI can write simpler code and the compiler will make it more performant. It's a really cool win, and it seems like Ryan now is seeing it. This goes back to leaks and abstraction, which make complexity real. Yeah, we get it now. React is absolutely its own language. It has been for a bit, but this is the like tripling down on it. I'm kind of disappointed that to my memoization questions on interviews, everyone can now just answer with, just use the compiler, man. Very fair point. The other times our renders are stupidly slow. This is why. You guys got to watch my React compiler content. I go so deep on these things and no one cares. It's, yeah. I think we're more aligned now. I see why, like in a literal, like especially a framework author sense, that the code you write with compiler less describes what the code does than the code written without it, where you're memoizing everything by hand. But the fact that those behaviors are different isn't a thing most React devs understand. And the intent of the average React dev is more aligned with what the compiler does than what the vanilla React code does. Anyways. Ryan goes into the AI thing. This will be fun. If compilation and bundling are fundamental, it's clear at this point that there are foundational pieces for giving AI the tools that it needs to create very dynamic solutions in the future. While we are seeing bigger impact every year on what these tools are capable of in improving our local developer experience, AI's impact on JS frameworks themselves is still pretty minimal. Earlier in the year, we saw Devin make headlines by creating simple apps, although it did call into question what our expectations are from the technology. Is it simply enough to make something functional, or does it need to be good? By the time this video is out, my project will be out. I'm building the best AI chat app right now. It has taken a lot of work. I'm really proud of what we have. You'll get to see it very soon. I think the reason that a random person like me can build a better AI chat app than OpenAI with ChatGPT or Anthropic with Claude is because their focus is on the models, not building great applications. And they, for the most part, are probably using the AI to generate half the stuff they're building anyways. Am I using a lot of AI gen code? Yes. But I am all in focused on a high quality, local first, really good client side experience. Try it when it comes out. You'll see it very soon. Friday's going to be a fun announcement. But yeah, I think that not every app needs to be really good and local first, but some benefit from it meaningfully. And I don't think the AI is going to figure out those nuances anytime soon. Devin decided to build a client-side rendered to-do app in about 130 kilobytes of JS. It scored a 79 in Lighthouse. As poor as that score is, it is pretty representative of where things are today. It will be interesting to see how the technology grows to meet the scaling complexity. I agree. It'll be very interesting to see. In the sense that tech like Vercel's V0 has been largely a success at creating prototypes, maybe that's where the biggest benefit is right now. The Million.js dev, Aiden, got our attention again with React Scan, which scans your app for performance issues. My React Scan video will hopefully be out very soon. You'll see here when you type inside of something like Slack, everything constantly re-renders because of their weird keyboard focus layer. That's not good. That's not good at all. They should use the compiler. Well, one might argue that re-renders aren't necessarily a sign of a problem, or that this exercise of finding re-renders in React is like shooting fish in a barrel. It definitely opened my eyes to the potential of development tooling just around the corner. If tasks are complicated and core tooling is more complex, it makes sense that supporting tools rise up to meet that need. It's more than a shift left in development. The need is fully integrated across the whole spectrum. While Biome and previously Rome set out on this goal, newer players in the space like Void Zero from Vue and Veet's creator Evan show that this foundation is essential to where things need to go next. Looking forward, server second. We've already started seeing some of the swing back of the pendulum towards the middle of 2024 with single-page app models in SvelteKit, Solid Start, and Remix. I've already slightly spoiled that I'm building a chat app. I want to show you guys something first. I changed how I'm doing it. Here is the whole app. It's a route named static app shell that renders app. App is a React router. I'm rendering a full React router client-side single-page app inside of Next because it is a marginally easier way for me to do the weird back-end front-end relationship stuff and having some static pages. It's been really nice. I don't think most mere mortals should touch something as chaotic as this, but I've had fun with it. You'll get more explanation in the future, but making this work was pretty simple. I have this rewrite that points every path to my static app shell. I brute forced my own traditional single-page app into Next because Next did not want me to make a traditional single-page app. There's a future where I move this to something more sensical, like a basic Vite setup, but for now, I'm getting the best of both worlds by inventing them all myself. But even I am going back to SPAs a bit here, so it's a very fair point Ryan makes. Remix ported back their non-server functionality to React Router. Solid Start's additive approach to server functions and single-flight mutations has laid down the eventual foundations for TanStack Start, which is a React framework built on the same principles. I don't know if you guys know how closely Tanner and Ryan work together. You wouldn't think so, because like Tanner's the React guy and Ryan's the creator of Solid. The amount of cool shit I've seen built between those two and the opportunities I've had to be like on the couch next to them as they nerd out is some of the coolest experiences I've ever had. I owe the two of them, as well as Fred from Astro, so much of my career and success. They were the ones who caught on to me before I was anybody and like pushed me to be here today. So huge thank you to all of them. Some of the coolest things that have ever happened in my life were seeing the sparks fly between those three. Makes so much sense that, as funny as it sounds, like Tanner is taking what we have learned from Solid back to React with TanStack Start, but he absolutely is. This is worth calling out. Next is trying to lean more into building traditional SPAs with it. They're not ready yet. I'm happy they're working on it. I like my way better. We've also seen an increase in local first and sync engine tech I agree. We have no idea where it's going to go because the need for local first, it's real for some percentage of apps, but any 3 local first apps have very, very different needs. Yeah. Slow and steady wins the race. I wouldn't read too much into that chart. The growing dissatisfaction is an important thing to call out. I have a whole video about that, but it's worth noticing how many of these tools are going down right now. Preact slowly plummeting, Angular dying, and then having a huge resurgence last year with all the changes that have been going on. React slow decline as well. Most of these tools have sentiment going down, not up. These aren't tools that I necessarily talk about as much. When the economy is tight and maintenance is a concern, those things tend to shine. Stuff like Vue, Angular, and OG React. So are all frameworks that Ryan's had in his eye on the coming year. Not because I expect to be blown away by some innovation, because these tools go the extra mile in making devs happy. Sometimes the best tool isn't the best tool. Why do you keep dropping these things that break my brain, Ryan? I can't process this right now. I'll think about that one more. He's right, but it hurts me. Signal growing pains. The hype cycle. Is this going to be about how signals were a huge hype thing and now people are rethinking it? This will be fun. It's no secret that pretty much all non-React frameworks run off signals now, even like Angular, which is hilarious. Some time has passed and developers are starting to understand the depths of the trade-offs present. While it's this author's biased opinion that these are minor issues, guy who made signals a really big deal, Ryan here, I can get why you'd think that. He does expect people to come to a new appreciation for React. I know I have. I did write a couple projects in Solid and it is an incredible framework. But there are certain things you can just do in React that are nice you don't think about when you live in those other spaces. It's an appreciation they should have probably always had, and that doesn't excuse any of React's flaws. Everything is a series of trade-offs, and you can only appreciate the choice you've made once you understand both sides. That being said, signals are still evolving. The collective experience in this area has grown immensely over the past few years. I expect the collective result of smaller innovations over the next year will showcase the unique value prospect of this approach in ways we've never seen before. The web component snipe at the end. I appreciate you, Ryan. And the link is to his other article, Web Components Are Not the Future. 10 out of 10. Loving this. The conclusion. Unlike previous years, I'm not predicting some big technology leap in the next 12 months. I don't know if the community at large would be that accepting. I agree. We don't want big things right now, especially with AI that's going to have to learn them. I've watched the conversation devolve from whether resumability makes sense versus partial hydration to who has the best templating syntax again. God, that tweet, comparing the if statements across language, I want to die. This is part of the cycle that lends to a reflection as well as innovation on the horizon, but not today, and that's okay. I am a little scared we're nearing the end of innovation for web technologies, but that's, again, I have decided the React's the last framework thing, this will be its own video that I'll record sometime soon. A lot to talk about there. We have a lot of complexity to catch up with first, though. A lot of hard decisions to make on what technology is worth our investment and effort. The raw capabilities for the next generation of solutions exist now. I'm not sure we've seen the right combination of pieces yet in a consumable form, but at least we're beginning to acknowledge that in our quest for simplicity, we set ourselves on a path to add back that complexity in new, unique ways. A single solution hasn't shown itself. HTMX is not going to take over the world, but it's a great option to have. React isn't necessarily any more complex at doing things than other solutions. Async and client-server interactions, by extension, are inherently a complex thing. Compilers can't solve all these issues, but they can do a lot. React compiler doesn't seem, when you compare it to really well-optimized code, like it's doing great, but when you compare it to React code that has no optimizations, all of a sudden you realize, oh yeah, things were really bad pre-compiler. As Ryan said here, it's pretty safe to say, even if the compiler won't make React itself faster, it will likely make your React code faster. Yep, and that's what's so cool. You can write simpler code and have faster code as a result. It's funny, the people who never learned memoization are the real winners because they don't have to go gut a bunch of old shit. We live in a world full of complexity, and that doesn't appear to be changing anytime soon. So 2025 feels like a good time to hunker down and get stuff done. And for those looking for the next great thing, look around. There are plenty of interesting problems to solve. Between you and me, this is the type of environment that I thrive in. Totally agree. And I am genuinely really hyped for what will probably be a boring year of JavaScript, but what will set us up for a long-term, chaotic, exciting future. Thank you to Ryan, as always, for writing this article, and thank you to all of you for sticking through these 2 chaotic videos. I hope this helps you feel a bit better about where we're at with JS and where we're going to end up. Until next time, peace, nerds. Read the first comment. Fine. React is dead. I am so excited for my React is the last framework video now. This is a much better end note.